These scientists just won a Nobel Prize for discovering a new phase of matter called time crystals. Time crystals are one of those scientific discoveries that sound more like science fiction than reality because they seem to break the laws of physics. But they real and they might change everything we know about the universe and even help us build better computers. So let me explain what time crystals are, how they work, and why they're so important. All matter is made up of atoms, which are really complex and made up of smaller particles called protons, neutrons, and electrons. Electrons are negatively charged particles that are always in motion. You can think of them as constantly buzzing around the atom. This buzzing creates waves of electron density that spread through the atom and are called electronic structure. The type of electronic structure an atom has determines its chemical properties, like how it will interact with other atoms and whether it will form bonds. That's because these structures determine how easily electrons can be added or removed from the atom. And chemical reactions happen when electrons are transferred from one atom to another. In normal materials, this electronic structure is fairly static. It doesn't change much over time, but that's not the case for time crystals. In these special materials, the electronic structure oscillates or fluctuates periodically, like a wave crashing into the shore again and again and again. This oscillation repeats itself in a regular cycle that can last trillions of years. So unlike regular crystals where the electrons are static, in time crystals, the electrons are always moving, but they do it in a very particular and repeating way. And here's the kicker. Unlike regular crystals, which have to absorb energy to maintain their structure, time crystals don't. They just keep oscillating indefinitely. Now, this seems impossible because according to our current understanding of physics, things need energy to maintain order. Without energy, things tend to move towards disorder or what scientists call entropy. Think about your bedroom. When you stop putting away your clothes, they eventually end up all over the floor. You need to keep putting them away to maintain order, just like adding energy to a system. Otherwise, things will naturally go to disorder. But somehow these time crystals manage to stay ordered without any input of energy. And there's only one possible explanation for that. They're drawing their energy directly from the fabric of space-time itself. And that's why they're called time crystals, because they're a crystal of time. They exist in a state of minimum energy, but they still manage to change. They exist outside of time, but they still manage to oscillate. They're a kind of perpetual motion machine. Okay, I'm getting ahead of myself. While scientists have observed this behavior in certain materials, we don't actually know if they're tapping into the fabric of spacetime. This is still speculative, but what we do know is that the phenomenon violates the second law of thermodynamics. The second law says that entropy wins every time, but these time crystals seem to defy that. Some physicists say that time crystals are actually not crystals at all because they do and follow the usual rules that we associate with crystals, which makes sense since they're a new phase of matter. But the discovery of time crystals forces us to reconsider what we think crystals should look like, which means we may need to rewrite some of our most fundamental laws of physics. There's also talk that time crystals could revolutionize quantum computing. That's because time crystals are made of two types of atoms, a majority and a minority. The majority atoms form the time crystal lattice, while the minority atoms sit in between the majority atoms and affect how they behave. Minority atoms are the ones doing the computation. And because time crystals can perform calculations without an input of energy, they could allow us to develop computers that run indefinitely without any power. Imagine a computer that never needs to be recharged. Now, the idea of a perpetual computer sounds cool, but it does beg the question, why haven't we discovered time crystals sooner? Well, it turns out that they were actually discovered back in 2012, but no one noticed. Here's why. Imagine you walk into a forest and see a bunch of trees swaying in the wind. From far away, it looks like the trees are staying perfectly still. The motion of the trees is too fast for you to perceive. Similarly, time crystals appear to be motionless on the scale of human perception. It takes billions of years for one cycle of fluctuation to occur. So time crystals were basically invisible to us until recently. It wasn't until scientists developed new methods for creating and detecting ultra-cold matter that they were finally able to observe these exotic materials. But once they realized what they were looking at, they knew this was a big deal. In 2017, the experimenters published their results in the journal Nature, and the world took notice. Suddenly, everyone was talking about time crystals and how they might change the world. In fact, many physicists believe that time crystals are the key to solving some of the biggest mysteries of the universe, like the arrow of time and the beginning of the universe. You see, we generally think of the universe as having a beginning and an end. Big Bang, start, finish, but that's not necessarily true. There's a good chance that the universe is actually infinite. We probably just live on a little bubble of space-time called a brain, and this brain is constantly inflating. As the brain expands, new matter is created, stars explode, black holes evaporate, and galaxies spin. All the stuff we associate with the universe existing, but it's all happening on a tiny patch of what could be infinite space-time. Scientists call this part of the universe a pocket universe. Our pocket universe is like a frame in a movie. There are countless other frames that make up the entire universe, each representing a slightly different version of reality. If that sounds crazy, it's probably best to stick with science videos. But anyway, these frames or patches of space-time aren't the same. Each one has its own unique features and characteristics. Some are hotter, others are colder. Some have more matter, others have less. One of the differences between these patches is how fast time passes. Patches where time moves faster essentially age more quickly. On these patches, stars explode and die out, black holes evaporate, and galaxies decay into boring balls of plasma. Other patches, however, are younger. Their stars are just beginning to form. Their galaxies are just coalescing. So the question is, if some patches of space-time are older than others, then where did time come from? If time is a property of space-time, then it must have been created during the Big Bang, along with space. But how can something come from nothing? Well, scientists now think that time was actually created by fluctuations in space-time, just like our time crystals. These fluctuations are extremely small, but they have a profound effect. They're responsible for the arrow of time. They're also responsible for the Big Bang. Here's how it works. You see, in our universe, time only moves in one direction. It goes from past to future. This is called the arrow of time. But in a perfectly symmetrical universe, time should be able to flow in either direction. Just think about a movie. You can watch it from beginning to end or from end to beginning. Nothing changes, but in our universe, we can only watch movies forward. We can't turn back time and see the chicken hatch from the egg. That's because our universe isn't perfectly symmetrical. It has a direction, but why? Well, scientists think that these tiny fluctuations are responsible. They created a small asymmetry in space-time, which gave rise to the arrow of time. As these ripples spread throughout space-time, they caused matter to clump together and form the first stars and galaxies. These fluctuations gave rise to everything we see around us. Some scientists think that this is because our universe is actually a time crystal, a giant crystal of space-time. The crystal lattice is formed by quantum fluctuations, and the arrows of time emerge from the regular oscillations of this lattice. Here's the crazy thing. These time crystal fluctuations might have started the universe in the first place. Scientists are currently investigating whether the Big Bang was actually a quantum fluctuation that caused our universe to pop into existence. To understand why this might be possible, we need to take a quick detour into the bizarre world of quantum mechanics. One of the weirdest aspects of quantum mechanics is that it allows for multiple possibilities to exist simultaneously. This is called a superposition. You can think of a superposition like Schrödinger's famous thought experiment with a cat that's both dead and alive until you look in the box. But superpositions aren't limited to cats. They're also present in our everyday reality, like in the electrons that buzz around atoms. But sometimes the wave function doesn't collapse. Sometimes the electron stays in a superposition. When two electrons are entangled, the state of one electron is linked to the state of the other. If you measure the state of one entangled electron, you instantly know the state of the other, no matter how far away it is. Entanglement is what gives quantum computers their awesome computational power. It's also what scientists used in a recent experiment to create time crystals. Then they used lasers to entangle the atoms and create a lattice. This lattice behaved like a time crystal. It had a repeating pattern of electron density that oscillated regularly. This is pretty crazy because it means that time crystals are basically made of entanglement. What's more, the researchers showed that these time crystals could be used to perform calculations. They basically created a primitive quantum computer. Now this is just the beginning. Thanks for watching, and I'll see you in the next one.